our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your computer based numerical and statistical technique, which has been the CBNST class here, and this has been classes your 38th class of the session. In this we had done your 37th class of the session in the last classes, and here we're gonna start with this 38th class. And in that before that classes we had done your unit 1, which has been the computer arithmetic errors and rules of equation, which we had done, where we had done your bisection method, second method, iterapson method, and many more methods we had discussed about it. And even though we had started with unit 2, which has been the interpolations and curve fitting, which we have to discuss here. And so first of all, before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And on the same phase, a huge support from your side required of. And as you had supported last dated, you've just been supported us, and that has been very appreciated. So we start with the question that is to be obtain the uniform approximation of the degree 3 or less to fx is equals to x ki power 4 in an interval of -1 and 1. So we go ahead. Obtain the uniform approximation of degree 3 or less to fx equals to x ki power 4 in an interval -1, 1. So for that, let us express the fx equals to x ki power 4 with the help of Chebyshev polynomial. So for that we'll have to do it. X power 4 equals to 1/8 t4x plus 4t2x plus 3t0x that we have. So here, since the polynomial of the degree 3 or less is required, we have to consider only t0x and t2x, hence approximation that will become pnx equals to 1/8 4t2x plus 3t0x equals to half t2x plus 3/8 t0x here. Putting for t0x and t2x, we get pnx is equals to 1/2 2x square minus 1 plus 3/8 into 1 equals to x square minus 1/2 plus 3/8, which is equals to x square minus 1/8. So the maximum error in the above approximation over the interval -1 and 1, that will get you x equals to max fx minus pnx. Putting fx and pnx is equals to, will be getting it max x power 4 minus 1/8 4t square x plus 3t0x, and we are putting with the x4 from the equation, we'll get here that will be having as equals to max 1/8 t4x plus 4t square x plus 3t0x, that has been minus 1/8 4t2x plus 3t0x, so which has been equals to max 1/8 t4x equals to 1 upon 8 max, the value will be minus 1, less than equals to x less than equals to 1, which is t4x here that we have. Now we know that our maximum value of t4x is plus minus 1 in an interval of minus 1 and 1, and hence e of x is equals to 1 upon 8, and this is an error in approximation. We'll go ahead for the next question that we talk about it. Using Lang's axiomatization obtain uniform Chebyshev's polynomial approximation for fx equals to e to the power x over an interval minus 1 and 1, the error must be less than 2%. So for that we'll have to solve it out. Lang's economization obtain uniform Chebyshev polynomial approximation for fx equals to e to the power x over an interval minus 1 comma 1. The error must be less than 2%. So for that, exponential function ex that can be expressed in the series is fx equals to ex equals to 1 plus x square upon 2 plus x cube upon 3 plus x4 upon 4 plus x5 upon 5 plus, so it will give you 1 plus x square upon 2 plus x cube upon 6 plus x4 upon 24 plus x5 upon 120 plus x6 upon 720 plus x7 upon 5040 plus. So here for putting that one that has been t0x and x, or just I will tell you, putting 1 equals to t0x and x is equals to t1x and x square is equals to 1 upon 2 t2x plus 20x. So we'll put the value x cube equals to 1 upon 4 t3x plus 3 t1x, x4 equals to 1 upon 8 t4x plus 4 t2x plus 3 t0x. So x5 1 upon 16 t5x plus 5 t3x plus 20 ti, which is t1x. For x6 equals to 1 upon 32 t6x plus 6 t4x plus 15 t square t2x plus 10 t0x. So for fx it will be t0x plus t1x plus 1 by 2 into 1 by 2 t2x plus t0x plus 1 by 4 into 1 by 6 into t3x plus 3t1x plus 1 by 24 into 1 upon 8 t4x plus 42x plus 3t0x plus 120 into 1 upon 16 t5x plus 5t3x and plus 20 tix plus 120 into 1 upon 32. So 1 upon 720 into 1 upon 32, and that is being, we have your t6x plus 64x plus 15 t2x plus 10 t0x here that we have, and further we'll get your answer here. So for the same we get 2917 upon 2304 t0x plus 109 upon 9061x plus 139 upon 512 t2x plus 17 upon 384 t3x plus 7 upon 1280, that is being t4x. Further we'll solve it out and that will find it out as well. That is in the form which is being plus 1 upon 1920 t5x plus 1 upon 23,040 t6x plus, so hence the error must be less than 2%, means that epsilon x is less than equals to 0.02. Let us see the error. If we discard the terms of the third and the higher degree, then error in a approximation that will be, so we'll get for the same x equals to max 17 upon 384 t3x plus 7 upon 1280 t4x plus 1 upon 1920 t5x plus 1 upon 23,040 t6x. So since the maximum value of the t and x are 1 and in the interval of -1 and 1, so we go ahead. So for that it will be equals to 17 upon 384 plus 7 upon 1280 plus 1920 plus 23,040 equals to 0.05, and that has been 5%. So we discard the second degree term also, and then we'll get second x equals to 139 upon 512 plus 17 upon 384 plus 7 upon 1280 plus 1920 plus 23,040, which will give you 0.3218, and that has been giving you 32%. So hence, to keep an error less than 2%, we should take an approximation up to 2 degree. Thus a form equation here, so we get it pnx equals to 2917 upon 2304 t0x plus 109 upon 96 t1x plus 139 upon 512 t2x putting t0x, t1x and t2x, so we get pnx equals to 2917 upon 2304 into 1 plus 109 upon 96 x plus 139 upon 512 into 2x square minus 1, so we'll give you 0.543 x square plus 1.135 x plus 1. We go ahead further, which we'll discuss about it, and that has been explained that in conditioning in least square method, and of course that has been the important one. So we go ahead. Explain L conditioning in least square method that we talk about it. So in that, when the coefficients of the normal equations that differ by a large value, that conditioning arises in the least square method of the curve fitting. In the least square method involves the summations of squares, cubes, etc., that has been powers and products of their data values. These summations from a coefficient of simulations simultaneous linear equation. While solving these equations, ill conditioning arises because of the large differences in the coefficient here, and so that the ill conditioning can be avoided with the help of the partial pivoting and iterative refinement, increase in precision of numbers that can also reduce ill conditioning as well, and the use of the orthogonal polynomial that can also be used to reduce the problems of ill conditioning. So for that we'll go ahead, and that has been write an algorithm for Lagrange interpolation. So write an algorithm for Lagrange's interpolation. So for that, in step 1 we have to do, there are steps so that we go ahead. So in step 1 you have to read total numbers of data points and read actual value of these data points, that has been x and y, which is equals to fx. So read total number of data points and read actual values of these data points, that is x and y, which is equals to fx. Okay, now we go ahead for the step 2, which we talk about it. For step 2 it will be read the value of x equals to xr at which the value of y is to be calculated. Read the value of x equals to xr at which value of y is to be calculated. Now for step 3, and that is if there are n plus 1 data points, then calculate. So what you have to calculate, that is being LK x is equals to P n I equals to 0 and I does not equals to K xr minus xi upon p n I equals to 0 and I does not equals to k, xk minus xi. So then calculate yr equals to 6 sum of n k equals to 0 yk lk x. In step 4 that we talk about it, the interpolated value of the interpolated value at x equals to xr is equal to yr, that is mean fxr equals to yr. Now we move ahead for the step 5, which is being you have to display values of xr and fxr on the screen and stop. Now we go ahead for the next that we talk about the another question. Write an algorithm for the Newton's divided differences interpolation, and that is being the important and very important, which we have to talk about it. So we go ahead for the same. Write an algorithm for the Newton's divided differences interpolation. So for the step 1, it would be read a real number of the total data points and the values of the those data points, that is x and y, which is y equals to fx. So we go ahead, real number of total data points and values of those data points, that is x and y equals to fx. So in step 2, read the value of x equals to xr, at which y is to be interpolated. So step 3, you have to calculate divided differences. So for that it will be y x1 x0 equals to y1 minus y0 upon x1 minus x0, and for the same it will be y x2 x1 x0 equals to y x2 x1 minus y x1 x0 whole upon x2 minus x0. For the next it will be y x3 x2 x1 x0 equals to y x3 x2 x1 x3 x2 x1 minus y x2 x1 x0 whole upon x3 minus x0, and so on. It will be further move ahead, and that will be continuously until the question being end up, whatever the requirement of the question is being given. After talking about that, we go ahead further, and that we have, so in step 4 you have to calculate, that we have to talk about it. What we have to calculate is yr equals to y0 plus xr minus x0 y x1 x0 plus xr minus x0 xr minus x1 y x2 x1 x0 plus xr minus x0 xr minus x1 xr minus x2 y x3 x2 x1 x0 plus xr minus x0 xr minus x1 xr minus xn minus 1 y xn minus 1 till x0. Now we go ahead for the step 5. That is, we have that the interpolated value of y, the interpolated value of y at x equals to xr is equal to y r obtained in step 4, that is f xr equals to yr. The next we have, in the last step, step 6. For that it will be display yr equals to fxr and xr on the screen and stop. So here we're going to end up with, we'll discuss moreover in the next coming class, and that what will be important, of course. So we go discuss about it, and other than this we said here, so yes, we want to end up with this. And first of all, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this computer based numerical and statistical technique, we have to cover up many more. Even though we had done your chemistry for class 11 part 1 and part 12 for part 1, that is been the unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8 and unit 9 with their conversions, logarithms and anti-logs. After talking about that, yes, we had done many more, and that has been, we had done your ER diagram, we had done your we had done your ER diagram, we had done your which is the chemistry for part 1 of physics we have to start with, and part 2 for chemistry for class 11 we have to start with. And other than that, we are dealing with reasoning. In that we had done general mental ability. In verbal reasoning we had done general mental ability. In the logic reasoning, in verbal reasoning we had done series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completion of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of analytical figures, quicksand dice, and situation, conceptions of squares and triangles, figure formation, analysis, and practice question set as well. In terms of quantitative aptitude, we have started with arithmetical ability, where we had done operations and numbers, escape and escape of numbers, decimal fraction, simplification, square roots, and Euclid problems on numbers, percentages, substance and distance, percentage, profit and loss, ratio and proportion, partnership, that we discuss moreover. In computer-based numerical and statistical technique, we had done unit 1, which is in the computer arithmetic and rules of equation, where we had done your floating point arithmetic, machine abscond, round of errors, chopping error, truncation error, associative and distributive law of floating point arithmetic, inherent error, error propagation, numerical instability. In rules of equation, we have covered up the second method, neutral absent method, third fixed point iteration method for the simple rules and derivation of the rate of the conversions, adding and accelerations of the conversion, modified neutral absent method to the multiple rules, Burge Viety method for polynomial, Weierstrass method for the quadratic fraction, and computer algorithm for these methods as well. In Unit 2, we have to cover up the interpolations and curve fitting, where algorithm and the error analysis of Lagrange and the Newton's divided differences interpolation relationship in the various differences of theta used by linear interpolation, cubic spline interpolation, natural spline, Chebyshev's polynomial approximation, Langkow's economization of the power series. In curve fitting, we have to cover up the linear and nonlinear least square approximation, and then we have to cover up the L conditioning in the L square method, Gram schematic process, orthogonalization, computer algorithm of the least square curve fitting. In Unit 3, we have to cover up the differentiation and integration. In that, we have to cover up the method based on the interpolations and finite differences, Richardson extrapolation. In integration, we have to cover up the error analysis of trapezoidal and Simpson method, Newton-Cotes integration method, Gaussian integration method, Gauss-Lagrange method, Lobato integration method, Radau integration method, error terms containing in the integration method. In Unit 4, we have to cover up the solution of simultaneous linear algebraic equation, where we have to cover up the Gauss elimination method, ill-conditioned systems, conditions, number, successive and relaxative method, rate of the conversion, solutions of the ordinary differential equation. We have to cover up the single-step integration method, Range-Gupta second order, third order, fourth order method, and then multi-step method, predictor method as well. In statistical technique, we have to cover up the statistical hypothesis, type of hypothesis, type of 1, type 2 errors, level of significance, stance involving the normal distribution as well. So here we're going to end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.